It's 3 a.m. You're scrolling through space photos again. Distant galaxies, millions of light years away, somehow perfectly framed. Fine. Cool, whatever. Science is amazing. But then you land on a photo of our own galaxy, the Milky Way, taken from outside it. Except we live inside it. So who took that picture? And how?
Welcome back to StickHead. Let's actually figure this out. Here's a simple way to think about it. Say you're standing inside a stadium, and someone hands you a phone and says, take one photo that captures the entire stadium, start to finish. Obviously, you'd walk outside, back up a good distance, and take the shot from there. That's just how you photograph anything big. You get far enough away to fit the whole thing in frame.
So, can we do the same thing with our galaxy? Just back up far enough and snap a photo? Let's find out, using the farthest object humanity has ever sent into space. In 1977, NASA launched Voyager 1. It flew past Jupiter and Saturn, sent back incredible data, and eventually kept going, past the Kuiper Belt, completely out of our solar system. It's still traveling today, and it'll keep going until around 2036, when its nuclear power source finally runs out. So the question is, after all these decades, how far has Voyager 1 actually gotten? After roughly 45 years, Voyager 1 has covered about 23 billion kilometers. That sounds massive. But here's the problem. Our galaxy is at least 100,000 light years wide. To compare those numbers fairly, we need the same units. So let's convert light years to kilometers. 1 light year equals about 9.5 trillion kilometers. Do the math, and Voyager 1's entire 45-year, 23 billion kilometer journey only adds up to about 21 light hours. Not light years, light hours. At that pace, it would take Voyager 1 roughly 18,771 more years just to travel one single light year. And our galaxy isn't 1 light year wide, it's 100,000. So, using our farthest ever spacecraft, backing away from the galaxy far enough to photograph the whole thing from outside is completely, hopelessly impossible. Which raises an obvious question. If we genuinely cannot photograph the galaxy from outside, is NASA just making these images up? No. What's actually happening is smarter than that. We just can't do it the traditional way, where you step back and take one clean photo. So astronomers found a completely different method. Let's go back to that stadium. This time, you're not allowed to leave. You're standing right in the middle of the field, camera in hand. Instead of one wide shot, you take a bunch of separate photos. One of the stage, one of the left stands, one of the right stands, one of the opposite end, section by section, all from your one fixed spot. Then you take every one of those individual shots and stitch them together, like puzzle pieces, into one combined image. The result isn't quite as sharp as a single photo taken from outside, but you end up with a genuinely accurate full picture of everything around you. That's essentially what astronomers do with our galaxy. And this isn't a modern trick. This method has been building for literally thousands of years. Ancient civilizations noticed a strange band of light stretching across the night sky during certain months, then disappearing. That faint band is still visible today, if you're somewhere dark enough. No telescope required. People kept records of it, and of star positions in general. One of the most famous ancient records is the Almagest, compiled by the astronomer Ptolemy, who lived his whole life in Alexandria, Egypt. His model wasn't fully accurate, but his star maps stayed a reference for astronomers for centuries. Centuries later, in 829 CE, the House of Wisdom Observatory was built in Baghdad, considered the first astronomical observatory of the Islamic Golden Age. Scholars like al-Biruni, al-Khwarizmi, and Ibn Sina expanded on Greek astronomy, cataloged huge numbers of stars, and named star groupings, many of which still carry Arabic names today, like Suhail, Deneb, and Aldebaran. Fast forward to the European Renaissance, roughly the 14th through 17th centuries. Astronomers started precisely recording star positions across the sky, especially once Galileo developed the telescope. The first European to attempt a full picture of the galaxy's shape was astronomer William Herschel. He divided the sky into sections and took separate readings from over 600 different locations on Earth. By 1785, combining all that data, he produced what's still known today as Herschel's map of the galaxy. Over a century later, Dutch astronomer Jacobus Kapteyn ran a more advanced version of the same idea, tracking star brightness, spectral type, and radial velocity across 200-plus locations, working with 40 observatories, arriving at an updated model by 1917. That same year, American astronomer Harlow Shapley studied globular star clusters and made a crucial correction. Earlier models assumed our solar system sat at the galaxy's center. It doesn't. We're actually out near the edge. Around 1920, Edwin Hubble began his own observations and discovered something huge. The universe is full of galaxies, and nearly all of them fall into just three basic shapes: elliptical, spiral, and irregular. Remember that mysterious band of light ancient civilizations kept seeing in the sky? It closely resembles the arms extending from the center of a spiral galaxy. If our galaxy were simply spherical, we wouldn't see that dense band of stars concentrated in a single line across the sky. That observation helped confirm the Milky Way's spiral shape. In 2003, NASA launched the Spitzer Space Telescope, which collects infrared light, and confirmed our galaxy's center is a dense, bar-shaped cluster of older, redder stars, with spiral arms branching outward from it. There was still debate over exactly how many arms, 2 or 4. But NEOWISE, a wide-field infrared explorer launched in 2009, helped map it more precisely. 2 major arms, Perseus and Scutum Centaurus, 3 minor arms, the outer arm, Sagittarius, and Norma, and 1 small spur branching off, the Orion spur. That small spur is exactly where our entire solar system sits. So after literally hundreds of years of star charts, telescopes, infrared data, and generations of astronomers building on each other's work, that's how we ended up with an image of our own galaxy. Not a single outside photograph. Impossible, given the distances involved. But millions of individual data points stitched together into the picture we now recognize. And it's worth remembering, it's not necessarily 100% accurate. It's our best model, built piece by piece from right where we're standing. That's one question down. Got something bugging you at 3 a.m.? Drop it in the comments. Might be next episode. I'm StikHead. See you at 3 a.m.